So now we're going to look at 2007, question 3, part A. A lovely simple little question on the surface of it, but it's a nice bit of work to get it through it. So particle projectors, we know the speed, 7 root 5, angle alpha we don't know, and we're looking for two values of alpha. So just to show you what this is going to look like a little bit in reality, we're launching from here at 7 root 5, and it's going to land here. I'm going to call this point P, and that is 12.5 meters away. This is either going to be a nice shallow launch like that, or a much higher up and down one like this. Okay, so I should see two angles of alpha, one probably less than 45, one greater than 45. Okay, so let's lay out what we have. The initial velocity. Ux is 7 root 5 cos alpha, and Uy is 7 root 5 sine alpha. Okay, just get it down on paper, we know what we're talking about, we're not going to make silly mistakes. Now, at P, what do we know? Okay, I'm going to call time equals TP, because again, T is a variable in some of these ones. In this case, we're looking at T at a specific point. Sx, okay, distance in the x direction is going to be 12.5, and Sy is 0, of course, because we're back on the ground again. So these are little bits and pieces we can know and we can work off them. Now, let's begin to see how we can figure this out. We're going to use S equals ut plus a half at squared. Okay, I have accelerations, I have times, I have distance, I have initial velocity, I have all the bits to make this one work. Okay, so let's go to our first point. So part 1. Sy equals 0. I'm going to start with this one just because it looks a little bit easier. We may as well get the easy stuff out of the way before we deal with the hardest stuff. Alright, so that equals Uy Tp plus a half, G is negative because we're defining up as positive, Tp squared. Okay, and I don't know how to write it. You can probably skip this step a little bit if you're doing it, but I want to make sure you're clear where I'm coming from. So what we know is that 0 equals 7 root 5, Uy is sine alpha Tp, minus G over 2 Tp squared. Okay, so we're going to figure this out fairly nicely. Now, one of the things you're going to notice is that one value of Tp can equal 0. All right, 0, 0, the whole equation works out. And this is, though, at the start. This isn't relevant to our question, we're worried about a P, so we can actually lose that one altogether. So we now have 0 equals 7 root 5 sine alpha minus gt over 2. Okay, a little bit of rearranging, and we're going to get this in terms of t. We have gtp over 2 equals 7 root 5 sine alpha. So tp equals 14 root 5 sine alpha all over g. All right. Sorry, it's rather messagey. We'll make that a little bit clearer. So this is going to be one value of t. I'm going to be able to sub this into the next equation I get. So let's go make our next equation. Well, Sx equals 12.5. That's what we're interested in. So this is, using our equation down here, Ux by the time at P plus, well, the good thing here is there's no acceleration, so that goes to 0. So we have 12.5, 7 root 5 cos alpha by Tp. So now let's sub in Tp. 12.5, 7 root 5 cos alpha, 14 root 5 sine alpha all over g. Okay, looking a little bit ugly, but we're going to better way. It doesn't see it as become anyway nicer. So first things first, we'll leave that there, 12.5. Let's work out all these numbers. So we have, use our calculator for this, just again to avoid any little small mistakes. 7 by 14 by root 5 by root 5 is 5 by 5, 490. So all these numbers collapse down to 490. Cos alpha, sine alpha, all over g. Now, the eagle-eyed amongst you will notice that 490 is rather related to g. Okay, so we can actually sort this one out nice and tidily. I think we'll just fit it in on this bottom line here. So 12.5, again, do it on a calculator just to be sure. So 490 divided by 9.8 is 50. 50, and then use gets better and better because of course 50 and 12.5 have a nice relationship themselves. Cos alpha, sine alpha. Okay, let's do a last little bit of simplification up here. So we have 1 equals 4 cos alpha sine alpha. Now, good news, bad news. The algebra is much simpler, but we still have cos alpha and sine alpha with two different ways of having to look at that. So this is where we need to turn to our log tables. And this is one of these equations you do need to know. All right, it's in the log tables. It's worth even recognizing that it's there. So of course, the key thing we're going to use when we look at our log tables is that 2 cos alpha sine alpha is equal to sine 2 alpha. All right, so just lay that out here. 1 equals 2. That would be 2 sine alpha cos alpha. I think that's how they write it in the tables. So 1 equals 2 sine 2 alpha, which of course means sine 2 alpha equals a half. So 2 alpha is the sine inverse of a half, which means that 2 alpha is going to equal either 30 degrees, which is the easy one. Of course we do, okay, second function sine inverse of 0.5, and we'll get 30 degrees. We need to use the cast rule to get the other one. So if we look at the different quadrants, you're going to see the quadrant over here where sine is also positive, and 150 degrees is going to be the angle on that one. All right, don't forget the last little step, easy to let that slip. Alpha then equals 15 degrees and 75 degrees, which is just what we'd expected. Small shallow angle, a bigger steeper angle, one less than 45, one greater than 45. So there we are. Those are our two values of alpha.